Hello, everyone. In this lesson, I'm going to talk about the cases and the examples from your homework on infinite limits, i.e., I'm going to cover these questions, okay? It may not finish in one recording, and I will make another one, okay? So let's first get started. To get started on this, we like to see that the simplest model of all of infinite limit is 1 over x. Okay, we claim that as x approaching 0 from larger than 0, the output is infinity. Meaning it can be as large as possible. Well, x approaching 0 from negative size to 0, from smaller than 0, 1 over x approaching negative infinity. What does that mean, right? So we have this table, but I also prepared, okay, on the other side of the Excel worksheet, right? So the input and that one will be the output. And the input, of course, is x, and the output would be 1 over x. Okay, so we're going to see a change when x is approaching 0 from larger than 0. Okay, so let me just make a little adjustment so you can see better. Okay, so when x equals to 0.1, the output would be the reciprocal of 0.1, right? So that's going to be 1 over 0.1, which is right here, we should get 10. If x is getting closer to 0 yet, we get 0.01. 0.01 certainly is closer to 0, and its output is going to be 100. So we're going to see 100. And so if we get another smaller number, okay, and the output will be 1,000, right? 1,000. And we start to see this pattern as x getting closer and closer to 0, 0.0001, the output is going to be 10,000. So now if we get the input smaller and smaller, right? So the previous input divided by 10, right? So that's even closer to 0. And the output, okay, the output is going to be even larger. So if we let this pattern go, okay, let me show you all these. Okay, so now you can see as we get a smaller and smaller input, which is getting as close to 0 as possible, the output is getting as large as possible. So on this direction, numerically, you see that as x is approaching 0, okay, x is approaching 0, but from larger than 0 side, right? So that's going to be that's going to be, let me draw that 0. Hold on. Approaching 0, right? Oops. Sorry. Erase. Let me grab curl, draw. Okay, let me grab the draw. So that's approaching 0 from larger than 0. Okay, so that's what it means. The input is getting closer and closer to 0, infinitely close, right? So it's more like that's on the graph, meaning let me get the color coordinated. Okay, let me get the color coordinated using the blue because I want to use the blue to represent the input. Okay, let me delete the red. Okay, so the blue is getting closer and closer to 0 in this direction. So numerically, you can imagine all of these numbers getting smaller and smaller, getting closer and closer to zero from larger than zero. The output is getting larger and larger yet. And vertically, those red, okay, so this red is getting higher and higher yet. Okay, so from 100, that's the output for 0.01. If the input is 0.001, the output is going to be even higher. All right, so that sense, okay, so that tendency, which is a dynamic process, right? The output is getting larger and larger, right? You can never stop at any large number. If you give me one large number, I can always find another input to make my output is even larger. So that process we call positive infinity. Positive infinity. Okay. So this expression, okay, so this expression basically expresses this dynamic process. So for negative number is similar. So when we approach zero from smaller than zero, okay, smaller than zero, so let me show you that. Okay, so I'm going to clean this up. And we're going to show how we get to as close as possible to zero, right? So we can start with 0.1, but this time is negative. And the output, we still follow the same formula. Oops, sorry. I'm so sorry. Let me do it again. Stop it. Okay. No. Here we are. Return, and the output is negative 0.1. Okay. So that's going to be 1 over this output. That's the output, negative 10. Okay, so this is going to be approaching from the negative number side. Okay, so now if we have an input which is negative 0.1, the output will be negative 10. Okay, so if we have negative 0.01, okay, negative 0.01, which is the divided by 10, the output will be negative 100, right? So on that side, yes, as you can see, as the blue is this much, as the blue, which is the input, okay, as the input is negative 0.1, the output will be the red, which is going to be negative 10, all right, negative 10. If we keep this process going, right, so it's negative, as small as possible, as close to zero as possible, and on this side, the output is getting as large as possible, but negative very large, and therefore, so this process, okay, this process, as x is approaching zero, as x is approaching zero, okay, as x approaching zero, from smaller than zero, okay, smaller than zero, how do we express that? We use zero with a negative sign on the shoulder. And the negative infinity would be the red, okay, approaching approaching negative infinity, okay? So that's what it is. When we express what's a negative infinity, this is a negative infinity. when we express these two expressions, right? So this top expression is the top process when we're approaching zero from larger than zero, and the bottom one is when x approaching zero from smaller than zero. Okay, and so that's how we observe the picture. That's how we observe the picture. So with that understood, we're going to look at some of these examples in our homework. Okay, in our homework. So I have typed these questions. Okay, and you're going to see how this model we just covered is relevant for our work. Okay, when we need it, we come back. Okay, and of course we can do the graph. You can do the graph, but it's not really necessary once you understand the graph on the top. Once we understand the graph on the top, we could use it. And how do we use it, right? So first of all, let's look at the first example. In the first example, and obviously we cannot do direct substitution. We cannot direct substitute. We cannot direct substitute because it's going to cause zero denominator. Since it's going to cause the zero denominator, right, we cannot directly substitute. Therefore, we're going to analyze. Okay, we're going to analyze. We analyze, and we realize that when x is approaching 5, okay, from larger than 5, you'll be thinking of 5. So numerically, you probably would be thinking, let me get the Excel worksheet again, right? Let's go down. So when we think of number larger than 5 and approaching 5, right? So that's the input. What does it mean that 5 to the, approaching 5 from larger than 5? So you'll be thinking of 5.01, which is pretty close to 5, right? You will also be thinking of 5.01 is even closer to 5, but they're larger than 5, right? So the input larger than 5, right? Input larger than 5. And even closer, 5.01, 001. So you think of these numbers. So that's what's on your head. That can be what's on your head. Of course, it could be other number that, larger than 5, but approaching to 5 as much as possible. So as we are getting closer and closer to, even closer to 5, right? Let's observe what happened to x plus 5. This should be x minus 5, isn't it? Did I make a copy error here? X minus 5. Boom. I'm sorry. X minus 5. Okay. So then we still have chosen the denominator properly. Well, x is approaching 5, and that is getting closer and closer to 5. Let's see what is x minus 5. Okay, the input minus 5. X minus 5, that will be the input minus 5. Right? We can see that number is getting closer and closer yet to 0. Do you guys see that? Right? You can see these numbers are getting closer and closer to 0. So it's when x is approaching 5 from larger than 5, x minus 5 is approaching. Okay, so let me use some symbols so you get familiar with the symbols. When x is approaching 5, okay, from larger than 5. That direction. So we keep choosing number that as close to 5 as possible. The output, okay, so the output, the x minus 5, not the total output yet. X minus 5, which is the denominator, is approaching what? Is getting closer and closer to 0. Hold on a second. I think I made a repetitive. I made a repetitive. I make it 0, 1. Okay, so let's make it 0, 0, 1. Okay, so this is make it just add a few more zeros. Okay, you can see as input getting closer and closer to 5, but larger than 5, so that we say x approaching 5 from larger than 5, then x minus 5 is approaching, x minus 5 is approaching 0 from larger than 0. Okay, so this column is approaching 0 from larger than 0. And what happened to the numerator? The numerator, as x approaching 5, is going to be approaching 6, which is a finite number. So let me write it down with our notation. Okay, so x minus 5 approaches 0 from larger than 0. And the numerator, on the other hand, which is x plus 1, is approaching 6. 6 is a finite number. So this quantity, x plus 1, is approaching to a quantity which is the numerator is approaching 6. Denominator is approaching 0 plus. As a finite number, you can see this is more or less related to what we have done here, right? It's very much similar, isn't it? It's very much similar. Yes, in our model, the numerator is 1. But whether it's 1 or 6, they're finite number. The denominator is approaching 0 from larger than 0. So that's how we can make a connection, because they're similar process. They are a similar dynamic process, and therefore this will be approaching positive infinity. Okay, so that's how we can see it. So as a result, now we can say this limit is equals to positive infinity. Okay. By similar manner, okay, similarly, okay, and of course I have a typo here, is x minus 5, right? So x is approaching 5 from smaller than 5, If x is approaching 5 from smaller than 5, what will happen, right? So we talk about input smaller than 5 and approaching 5. So what are the numbers we're talking about? We're talking about the 4.9, right? 4.99, 4.999, right? And we're talking about 4.99999, right? So as close to 5 as possible, but smaller than 5. Okay, so we can let this process keep going. Let's do one more. Make it like, more 9. In this case, x minus 5, what will happen to x minus 5? What happened to x minus 5? It will be this input minus 5. What do we get? You can see we get a bunch of negative numbers, but each one of the negative numbers is getting closer and closer to 5. okay? So on this direction, we're going to write, okay? So mathematically, this is what we're going to write. You cannot use this number to making lists of numbers to make your case. But in your mind, you have this process in your head. So we will describe it as when x is approaching 5, okay? When x is approaching 5 from smaller than 5, so we're describing a process like this, okay? We're describing a process like, oh no, sorry, I'm gonna use blue for the input, okay? Just make that color coordination, okay? So that's what it describes that x is approaching 5 from smaller than 5. So let me draw 5 smaller than 5. Okay, so this dynamic process, but you're going to see in your mind, you see x is constantly getting closer and closer to 5 from smaller than 5. It's not going to stop anywhere. It just keep approaching 5 from smaller than 5. So we use x arrow 5 smaller than 5. And the consequence, okay, so what will be the consequence? The consequence would be the output, right? You see the output is getting closer and closer yet to 0, but smaller than 0. Okay? So now describe that process, and we will say x minus 5 is approaching 0 from smaller than 0. And now, once again, the numerator in this case, x plus 1, is still approaching 6, right? X plus 1 is still approaching 6. So the numerator is a finite number. The denominator approaches 0 from smaller than 0. And the process that we described above will be relevant as a comparison, okay? They're not exactly the same, but they're comparable. Okay? So similar to that. Okay, similar to that process. Okay, similar to when x approaching 5 from smaller than 5, therefore this one is approaching negative infinity. So we use these sort of mathematical language to describe that process. Okay. So let's see. I hope this is not too long, but let's look at a few more. Okay, so we're gonna get better at these. Okay, so that was question number 1. And this is question number 2. And in similar manner, let's look at the question number 3. Okay. In the case of number 3, right? In the case for number 3, because we use this so often, let me just put this down under. So when we need it, I will make a reference. Okay, instead of going backward to find them. So I'm going to keep it with me. So in this case, x is approaching 1. This time there's no one-sided limit. Okay, so when we observe this process, we see that x is approaching 1, right? And x minus 1, but this denominator is x minus 1 squared. I'm sorry, x minus 1 squared. So that square make positive, right? That square makes positive. So this is going to be approaching 0 from larger than 0. So denominator is approaching 0 from larger than 0. So this is a similar situation. What happened to the numerator? Numerator is 2 minus x. So when x is approaching 1, 2 minus x is approaching 1. approaching a finite number. Therefore, this model would be applicable here. Okay, therefore, we're going to say this is going to be approaching positive infinity. All right, now let's look at number 4. Number 4, right? X approaching 3 from smaller than 3. Okay, X approaching 3 from smaller than 3. So X is approaching 3 from smaller than 3. Okay, then X minus 3, what happened to X minus 3? X minus 3 is going to approach 0 from smaller than 0, right? Because every X is less than 3. It's getting as close as to 3. So X is less than 3. So it's going to be less than 0. But it's getting closer and closer to 3 from smaller than 3. So X minus 3 is going to be approaching 0 from smaller than 0. And since X minus 3 itself is a negative, so X minus 3 to the power 5, right? The negative sign multiplies itself 5 times. It's still going to be approaching 0 from smaller than 0. As a result, okay, so let's look at what happened to the numerator. The numerator, root x, as x approaching 3 from smaller than 3, is going to approach root 3. It's still a finite number. It's still a finite number. So in this case, this model would be, applicable. Therefore, this limit would be negative infinity. Right? You can see these two models actually are rather very, very useful. Very, very useful. Okay. Before we go on to other examples, we have some examples that are have something to do with trig functions and other functions. So I'm going to put those other examples as in another recorded lesson. And here I'm going to pick out 2 more examples, this one and that one. Okay, so I'm going to just switch the order. I'm going to put this one over here, whatever that number is. Okay, so in this lesson, let me see which is that number. That number is number 9, number 12. Okay, so this is number 9. And number 12. Number 12, I would choose this example over here. Okay, over here. And for logarithm and the trig functions, we're going to make another video, because I really don't want to make this too long. All right, so let's do number 9 and number 12. Number 9 and number 12. So how do we view these situations? Okay, in this situation, let's start from number 9. The first thing we do would be factoring it, because when we see a question like this, recall that what we did for other limit case, right? You may think, I got this question from a student and he said, how do you know this is going to be approaching infinity? Maybe it would approach a finite number, right? So maybe we just reduce it, pretend we don't know what's the result, even though these questions are given in the setting of infinite limit, but maybe we'll give it a try, right? So sometimes you're thrown a question, you don't know what's going to be, right? So you're going to try your way. And so now we're going to try our way. So this is going to be x minus 2. So we'll factor it. The denominator after factoring, we got x minus 2 squared. X minus 2 squared. Okay? Since x approaching 2 from smaller than 2, so x is not 2. X is not 2, x minus 2 is not 0. Therefore, we can reduce. Okay, so we can reduce the x minus 2 from the top, and we can also reduce the other x minus 2 from the bottom. Oh, hold on. Let me not making too many mistakes. Okay, I'm going to keep this one. So that was the original. So here we left with x minus 2 under x. Okay, so we can remove the parentheses, double check. So in this case now, the question is reduced. So when x is approaching 2, from smaller than 2, x minus 2 is going to approach 0 from smaller than 0, isn't it? Right? The denominator is going to be approaching 0 from smaller than 0. So this model is applicable because the numerator is just approaching 2, right? The numerator is a finite number. Therefore, this limit is going to be negative infinity, right? This is going to be a negative infinity. You can see we learn how to use these models. Of course, you can do the graph. But you don't really need the graph, okay? Especially, I usually don't allow you to use a graph in the classroom, okay? Or I'm sorry, on the quiz, you can use a graph, and I do not discourage you from using the graph, but this is how you analyze it. So in your private time, use the graph, okay? You can use the graph if you wish, okay? But still learn how to do this like what I do here. Number 12. Did I copy the question right? Let me double check, okay? Okay, it's 2 plus, actually. 12 is 2 plus. My bad. Okay, plus. 2 plus. There we go. Minus plus. Okay, all right. And now for this question, of course, we're going to do factor again. To do the factor, you can factor any way you wish to, but you should get the same factors. Okay, the top is going to be x minus 4 times x plus 2. Double check the factoring. Okay, double check the factoring. And in this case, we cannot reduce anything. So it's just x approaching 2 from larger than 2. X minus 4 is going to be approaching a finite number. X plus 2 is going to be approaching a finite number. And x minus 3 is going to be approaching a finite number, right? So let's put that in our consideration, right? So as x is approaching 2 from larger than 2, okay? X minus 2 is going to be approaching 2. I'm sorry, it's going to be approaching 0 from larger than 0. We understand that. Okay, we understand that. So this piece is approaching 0 from larger than 0. Now, how about the other 3 quantities, right? The other 3 quantities, let's take a look. Under the circumstances, right? X minus 4 is going to be approaching 2 minus 4. 2 minus 4, which is a negative 2. And x plus 2 is going to approach positive 4. X minus 3 is going to approach, what does it approach? It's going to approach negative 1, right? So what happened is this quantity, right? As you take a close look, the whole thing, as you write it down, approaches x minus 2 is going to be approaching 0 from larger than 0. X minus 3 is going to be approaching negative 1. And x minus 4 is going to be approaching negative 2. And x plus 2 is going to be approaching what? X plus 2 is going to be approaching 4. Okay? So negative 2 times 4 is negative 8. And negative 8 divided by negative 1. So we can see this as a finite number, which is a positive number, which is actually 8 over 0 from larger than 0. In our head, we have seen that it's going to be this model. It's going to be this model. And therefore, right, it's a finite number divided by a number getting as close to 0 as possible from larger than 0. And therefore, this is going to be approaching positive infinity. So this is how we analyze it. Okay? And that's all for this lesson. Okay, I will make another one, so stay tuned. Thank you for watching.